You think astronauts float in space because there's no gravity? Wrong. They're actually falling toward Earth the whole time. And if you think rockets just fly straight up into space, that's wrong too. What really puts a spacecraft into orbit isn't flying high. It's flying sideways fast enough. Even weirder. Space isn't one giant freezer, and coming back to Earth isn't just steering downward. Hello, Earthlings! I'm 2Drew. Today, let's talk about 5 big myths that regular people get wrong all the time. Myth number 1. There's no gravity in space. This is probably the most common and the easiest one to fall for because the footage is so convincing. Astronauts drift around the cabin, drops of water hang in midair, and the moment you let go of something, it floats away. It really looks like they've reached a place with no gravity, but in reality, gravity has not disappeared in low Earth orbit. The space station is only a few hundred kilometers above the ground. The moon is about 384,000 kilometers from Earth, and Earth's gravity can still hold on to that. So how could it not hold on to a spacecraft just a few hundred kilometers up? Then why do astronauts float? The answer is counterintuitive. They aren't floating, they're falling. Imagine an elevator. If the cable suddenly snapped, the elevator would fall. And if you were inside, you'd fall with it. At that point, you and the elevator floor are dropping together, so your feet no longer feel supported. You'd feel like you were floating. Astronauts in orbit are basically riding in an elevator that keeps falling, but never reaches the bottom. So why don't they smash into Earth? Because they're falling so fast and moving so far sideways. A spacecraft is pulled down by Earth's gravity while racing sideways at enormous speed. In low Earth orbit, that's about 28,000 kilometers per hour. It's not that it isn't falling, it's that every time it's about to fall toward the ground, Earth's surface has curved away underneath it. So the result is, it keeps falling and keeps missing. That's orbit. Astronauts haven't turned on some zero-gravity cheat code. They're just extremely professional fallers. Myth number 2. Rockets fly straight up into space. That feels right to most people. Space is up there. So of course the rocket goes up. But that's only half true. Right after launch, a rocket really does blast upward, because it first has to punch through the dense lower atmosphere, where drag is the worst. At that stage, it has to fight air resistance, gravity, and its own weight just to pull itself off the ground. But once it gets higher, the thing that matters changes. It can't just keep going straight up. It has to start turning and building sideways speed. In launch videos, you often see the rocket begin to tilt as it climbs. Sometimes it doesn't even look like it's going straight up anymore. That's not a mistake. That's when it's finally doing the real job. Because getting into orbit is about speed, not height. As we said earlier, a spacecraft can circle Earth, not because it reached some magic altitude, but because its sideways speed is high enough. So a rocket's real job isn't to keep pushing the spacecraft upward forever. It's to push it to orbital speed. To put it bluntly, getting to space isn't the hard part. Staying up there is? Myth number 3. Do you also think a person exposed to space would instantly freeze solid? This idea mostly comes from movies. Someone is exposed to space. Frost forms on their face. Their body stiffens, like they've been thrown into a cosmic freezer. It looks great on screen, but the physics is not that simple. Of course, that doesn't mean exposure to space is fine. Vacuum, decompression, lack of oxygen, and the risk of body fluids boiling are all deadly enough. I'm only making one point here. You wouldn't necessarily freeze into an ice cube instantly like in the movies. First, here's something many people don't realize. You don't feel cold because cold is entering your body. You feel cold because heat is leaving it. When you touch ice, it feels cold because heat from your hand is flowing into the ice. When you stand in a cold wind, it feels cold because the air is carrying your heat away. On Earth, that happens all the time because we're surrounded by air, water, walls, and the ground. Heat can escape quickly through contact and through moving air. But space is a vacuum. There is no air there, so there is no cold wind blowing over you and no air to carry your heat away. In a vacuum, heat mostly leaves by radiation slowly, and that leads to a very counterintuitive result. In space, getting rid of heat is actually a big deal. Spacesuits need cooling systems inside, and spacecraft need radiators on the outside. The side facing the sun can get roasted, while the side facing away from the sun can become extremely cold. Space is not an ordinary refrigerator. It's more like an extreme physical environment with no air, no wind, and no buffer. On Earth, hot and cold feel easy to understand because Earth takes such good care of you. It gives you air, pressure, and a water cycle. Take all of that away, and human intuition starts to break down. Myth number 4. Things move in a vacuum just like they do on Earth. This is easy to overlook because almost every motion we've ever seen has happened in air. Paper flutters, feathers fall slowly, and smoke gathers into a column. Flames have shape. All of that seems normal. But behind it is something you usually don't notice. Air. Air is not nothing. It is constantly pushing you, pressing on you, and dragging on you. You've just lived inside this layer of air since birth. So you treat it like the natural state of the world. But in a vacuum, a lot of things suddenly get weird. At low altitude, a rocket plume is squeezed by the surrounding air, so it looks fairly tight. Higher up, as the air pressure drops, the plume expands outward, like a glowing cloud exploding across the sky. That's not an alien spacecraft, and the sky hasn't cracked open. It's just that once the air pressure gets lower, the exhaust plume finally isn't being held down anymore. Another example is the flag on the moon. People ask if there's no wind on the moon. Why is the flag moving? Because someone touched it. On Earth, when there's no wind, a flag swings a few times and stops, because air resistance breaks it. But in a vacuum, that invisible break is gone. So the motion lasts longer and looks unfamiliar. That's why so much space footage feels strange. Not because it's fake, but because you've spent your whole life inside a layer of air. Myth number 5. Returning to Earth just means steering downward. This one is the most dangerous and the most counterintuitive. You think, if the spacecraft is up in the sky and wants to come home, doesn't it just fly toward Earth? Just point down, right? The problem is that in orbit, the real challenge isn't height, it's speed. The spacecraft is moving at about 28,000 kilometers per hour. That is so fast that it can't simply drop down and come home. If you want a spacecraft to return to Earth, the first step is not diving downward, it's braking. It points its engine nozzle in the direction of travel and fires backward to slow itself down. Once it slows, its orbit drops, and the spacecraft can begin to skim into the atmosphere. But there's another problem. The angle has to be just right. Come in too shallow, and it can skip off the edge of the atmosphere like a stone on water. Come in too steep, and the heat and pressure hit too hard. The spacecraft may not survive. So coming home isn't just falling down, and that fireball around the capsule isn't simply friction. At those speeds, the air ahead is compressed so violently that it heats up and turns into plasma. During re-entry, the vehicle can be wrapped in superhot plasma, and comms may cut out for a while. Only after the atmosphere has scrubbed off enough speed, and the capsule is lower, can the parachutes open. Otherwise, a chute at that speed wouldn't slow you down. It would be torn to shreds. Launches look spectacular, sure, but re-entry is the harder engineering test. It's about bringing people back in one piece from high speed, vacuum, weightlessness, and extreme heat. So look at spaceflight again, and you'll see it's nothing like your instincts tell you. Out there, gravity hasn't vanished. Speed decides life or death. Vacuum changes everything, and the atmosphere isn't some gentle front door home. We can go there now not because space got easier, but because we finally learned how to survive by its rules. I'm 2Drudy. See you in the next universe.